In this video, we will discuss the second version of pedigrees that deal with sex-linked traits. So if you recall from last video, we went through a karyotype, and the assumption is that anything that is autosomal is found on 1 through 22 on this karyotype. That means males and females have 2 copies of each homologous chromosome. So that's why if there was a trait specifically found on chromosome 6, the genotype is designed for which allele is on the homologous pairing. So if I said dominant A was on the left homologous chromosome, again, this is mid-division, so a cell is not going to have the replicated state all the time. So you just look at one of the sister chromatids within that replicated state to get the genotype from one homologous chromosome. Then on the other, you potentially could have the other format or recessive. But for every trait that is autosomal, regardless if you're male or female, you're going to have 2 copies of that specific gene. But when it comes down to a sex-linked trait, the reason why males and females have a different notation is because of the fact that if there is a gene that is found on the X chromosome, which we discussed in previous videos on doing a Punnett square for sex-linked, that would be something where like colorblindness. If colorblindness is located for a male, they only receive one X chromosome. Colorblindness is not found on the Y chromosome. So therefore, the male genotypes are different because of that, where a female would have 2, I know the X chromosomes are just the same size. I know they look like X's, so it can be a little deceiving. But the idea that there is a gene on one homologous chromosome and a gene on the other homologous chromosome to give them 2 alleles per gene, that is sex-linked. So when we do a pedigree, sex-links can be pretty tricky to identify because they can kind of match the mold of autosomal very, very, very easily. So sometimes they have to be more generous with their information. They might tell you what the actual trait is that they're tracing, so you have to be comfortable with recognizing colorblindness, hemophilia, or muscular dystrophy. If they tell you it's one of those 3, that's their hint. Pick up on it, this would be then a sex-linked pedigree. Now, there are some things that have to occur. Sadly, sex-linked pedigrees that are recessive could also immediately fit the mold of an autosomal recessive, but it doesn't reverse that. If I look at a sex-linked recessive pedigree, I sometimes can rule out that it can't be sex-linked recessive, and I'll explain that at the end of this video. So to go through here, it is identified as a sex-linked pedigree. It doesn't say recessive or dominant. My hope is that you recognize, well, based on the shading pattern, this male gives it away. There is no way that he could have a dominant sex-linked trait with 2 parents of the opposing phenotype, which would be recessive. That's not possible. So that means he must have the recessive characteristic. So the way that you do this is just like how you would write the genotypes on a Punnett square. I'm going to go in and identify my X's and Y's based on the square or circle. So I'll do the ones I'm going to do first. If he has a recessive sex-linked trait, that means that on his X chromosome, he has the recessive. I'll keep the A version of this to make it easy. That would then mean that phenotypically, since they are unaffected, they both must have the dominant A attached to an X chromosome. Notice the males give away their genotype immediately upon their shading factor. The female is the one that we have to figure out what could be on their second X chromosome. And because she had a son, look at where these letters came from. The Y arrived from dad. The X with the recessive A had to arrive from mom. If mom does not show it in her immediate genotype, we must add it. She must be carrying that recessive allele. So then you go through and say, all right, male unaffected, that's X big AY. Female unaffected, X big A. Not sure yet what the second allele is. Is it possible that this XA could have come from either parent? Yes. And then we're just not aware if this is the X from dad, the X from mom could have either of them. So I'm just going to put a dash there because there's not enough information. Female affected by a sex-linked trait. Doesn't happen often, but it will occur. Female unaffected, we'll start with that. I'm not sure yet. I'll figure out male unaffected. male affected, female unaffected, female unaffected. So let's figure out these unaffected to see if we know. Since she has a mother who has only recessives and it's not showcasing in her immediate genotype, that must mean this is the X from dad. The other one must have come down. She must be a carrier. Then here, no information about her parents, so that's not helpful, and her daughter is unaffected as well. So I'm not really sure what this second allele is. That's going to be a dash. Dad has a daughter, unaffected, so we know that that XA that's dominant came from mom. So we have to account for dad's X, that's what made her a female, so therefore she must be a carrier. So this is an example of a sex-linked notation, how to do a sex-linked recessive. Now, what are some of the guarantees on a sex-linked recessive trait? A guarantee for a sex-linked recessive trait, usually you go to an affected female. She is your go-to. Like on an autosomal dominant, you go to the parents that are both affected and look to see if they have an unaffected child. That's a giveaway. If everybody's like 1 and 1, that's not really helpful to determining which one it has to be. Autosomally, you're always looking for a family where 2 parents share a shading pattern and a child is of the opposite. That tells you most quickly, is it autosomal dominant or autosomal recessive potentially? Then with sex-linked, I look for an affected female. Affected females must always have sons that are affected. If they have a son, he better be affected. If you look at the inheritance of his X and Y chromosome, his Y chromosome was passed down from dad. So the only X that he has must have arrived from his mother. And if his mother is affected, she only has recessives to pass down. So it's a guarantee. If a mom is colorblind, for example, every son that she is going to have better be colorblind or that is not her son. So if you look up here, this would be a giveaway. An affected female, an unaffected son. That's how I know this pedigree is not a sex-linked recessive pedigree. You know, if I'm just looking at literally that connection right there. All right, some other stuff would give that away equally, but if I'm looking just to kind of showcase that example, there is no other time where this female is connected to a male. If you look at an affected female, what else must be a guarantee for an affected female if she is carrying recessive? Not shown here, but if I did add a generation above her, what can you guarantee up here? I want you to think about that. Think about where these X's came from. She better have an affected father because she is a female because he passed down an X chromosome. And if both X's have an X with a little a, that means that the father above her better be affected as well. So that's the kind of go-to. If that is ever broken, the idea is that you can't have a sex-linked recessive pedigree. And that's the skill you're eventually going to try and build up to, is you're trying to look at a pedigree and prove what it can't be. And by default, when you knock down the ones it can't be, you leave the ones that it still has the potential to be. And unfortunately, some pedigrees have multiple options if they don't give you enough details. So this is a sex-linked recessive, showcased how to do the pedigree or how to do the genotypes for all of them, and the notation for when you don't know specifically what an outcome would be. But look for the clues, whether they tell you. You have to recognize these are all recessive. If they tell you the affected people have any one of these, your immediate thing is these are all recessives. So use that as your context. There are sex-linked dominant. I can't see an intro to biology class or test kind of going through that. But as a little sidebar, a sex-linked dominant trait, you look for affected males. Affected males, if they are dominant, they pass down their X dominant to every female. So males and the female daughters that they possess, if it's a sex-linked dominant trait, they have to have the same shading pattern. Just a little sidebar if you're curious about that. But that's what I wanted to go through. We can go through an example here and say, if I'm looking at this pedigree, can this be sex-linked recessive? So you can pause it, take a look at it. but look for the go-to person. The go-to person is always an affected female. Here's an affected female. Look to her above. Her father is affected, so that doesn't help me, because every sex-linked recessive's father, they must have the same shading pattern. But if you look to her sons, this defies the rule for the Punnett square. If she has X little a, there is no way that a son could have the opposing phenotype and be X little a y. The Y came from dad, so there's no way that this X with a big A arrived. So that means this scenario cannot be X-linked recessive. So it's just the way that you have to start looking at these. If they don't tell you outright what is the inheritance pattern, you have to start using your clues to rule out what it cannot be. Okay? So from there, I want to make sure the first question is this syndrome an autosomal or sex-linked disorder? What is the evidence? This is not a sex-linked disorder because of the fact that this mother-to-son scenario disproves its ability to be sex-linked. If you have any questions, we'll do some more follow-up in the future.